Hello?
Hello.
Hello. Nice to meet you. Ross, can you hear us?
I can indeed.
We are still waiting your presentation. Are you ready?
I am. Give me 2 seconds.
Okay.
Close down some things. Right, let's see if this works.
Black screen.
Okay.
Oh, yes, right now we can see you.
Okay, can you see the slides okay?
Yes, yes.
Excellent stuff. Am I good to go?
Yes, thanks.
Brilliant. Okay, well, thank you everyone. So I've been asked to give a talk about why use MongoDB and where does MongoDB come from. And this really is a talk about the journey going from a SQL relational world to a document database. So my name's Ross Lawley, and I'm a driver engineer for MongoDB. I work on the Scala driver, but I also used to work on a Python driver, and I run a Python ODM called Mongo Engine, which is kind of like a Django extension for Mongo Engine. So, when we talk about databases and we talk about MongoDB, a lot of people ask us, where does it come from and why does it exist? And to look and understand why Dwight Merriman and Elliot Horowitz went and built MongoDB, we've got to look at some history first. So, first off, where did relational databases come from? So, IBM in the late 1960s created and built an information management system with Rockwell and Caterpillar for the Apollo space program. And their kind of, the remit of their database system was to do the inventory for the large bill of materials, track all the pieces and the equipment needed, and all the logistics for the Saturn V moon rocket and the Apollo space vehicle. Now, back then in the 60s, that caused them a lot of problems and created a number of challenges for them. And at around the same time, in IBM, in the research laboratory, Edgar Codd was working, and he produced a white paper talking about the relational model. Now, this was internal to IBM in 1969 and went public in 1970. And it was only when it went public and some of IBM's rivals started using and implementing this relational model, IBM finally started to become interested in it. So what did Edgar Codd solve? What problems was he looking at? Well, for IBM, their main problem was the accounting for the materials for the space program. And how did they solve that problem? Well, or how did Edgar go and solve that problem? Well, he used ledgers. This is like an accounting mechanism for understanding and keeping track of your supplies and everything. And everyone uses ledgers in every business, from keeping track of your stationary supplies, your parts, your goods vehicles, your business assets, whatever it was. So it's no surprise when you have a look at the relational database, and it's very similar to a spreadsheet, it's very similar to an accounting ledger. So you have some normalized data out here. For example, we've got some people. And what Edgar Codd did was he looked at it and looked at how to store the information and the relations of that information clearly and concisely and efficiently on disk. So here we have a person's table and we have a car table as well. And the way he highlighted in the relational theory is to normalize that out and to store a foreign key linking back to the person. So in this example, we can see that Paul Miller from London is lucky enough to own a Bentley and a Rolls Royce. So that's where the relational world came from, and that's the problem that they were solving back in the late 60s and 70s. So let's have a skip forward and look at development today. and understand what's going on there. What's changed? Well, first of all, we can store more data than we ever could in the past, because relational modeling for modeling your data is extremely efficient for storage, and it had to be. In 1970s, storage was ridiculously expensive. In fact, in 1980, it cost over $500,000 to store a gigabyte of data. I don't even know how big a room that would have to have been in. In 1990, just 10 years later, it cost $10,000. In 2000, it cost $10. And in 2011, it's under 6 cents for a gigabyte. So we're able now, with this freedom of the cheap storage, to be able to store more and more data. What else has changed? Objects have changed. The way we program has changed. We've now gone more to an object-oriented programming paradigm. Arguably, it started in the 60s with Simula, but really started to become popular in the 1980s with Smalltalk. And if we go and have a look at the languages we're using today, that are the most popular languages, we can see it's dominated by object-oriented languages, and it will be for the mid to long term. So we've changed, we can store more data, we are using object-oriented languages to express our programs. What else has changed in the world? Well, the complexity of our applications has increased. And I don't know if you can see this, but this is a schema diagram for a shopping application. Applications now are no longer simple like spreadsheets. They're a lot richer. We store and we can afford to store more and more data. And we can store more relations between that data. The problem with these complex applications is the database that you're using, those models hide what you're actually doing. They're extremely efficient at storing data, and it's kind of like this deconstructed car. We have all the parts of the car laid out nicely in this picture, but as a programmer, what I actually need when I'm writing an application is a running car, not the parts. So if we have a look at how developers like to model this data, and this is an example from the Python world, which I also come from. Here we have a car and a manufacturer model, and we like, as a developer, I like using objects, I like using classes, reading the attributes from those objects, understand and use in my application. So with these, this is how, as a developer, likes to do it, and we store it in the database. How do we marry these two together? Well, traditionally, at least since the 2000s, we've been using things called object relational mappers, whereas I, the developer, want a car. I think a mind bubble there. And in my code, that's what I'm using. And in my schema, I'm storing the data as efficiently and normalized as possible. And in the middle, I have this magical software, which is the ORM, which relates and produces objects from the data that's stored in the database. And as a developer, to me, it makes sense to be able to use these objects, but what are the problems? Well, Ted Neward in 2004 called ORMs the Vietnam of computer science. Why did he do this? Well, there's always been a mismatch between the relational data model and the object model you're using in your programming. And there's no good solution to that problem. There are cracks in a number of places. So if we have a look, how do we solve things like polymorphism and inheritance? Do we have a single database table per class, or a concrete class, or per family? How do we store that? And different ORMs will store it and deal with the problem differently. We have a problem with where the schema is kept. The schemas for the data is modeled in the database. The schema is also held in the ORM code, in the application code as well. And if you want to refactor one part of that, you're going to have to change both of them, or you might have to change both. That means you have to do migrations, you have to do rolling code upgrades, and you have to do database upgrades. And at some level, this puts implicit pressure to make the model static, whether it's business pressure or whatever, because reversing out of a migration, I don't know if you've ever done it, is painful. The other side of this is because there are potentially two teams owning this schema, one owning it in code and one owning it in the database, that can cause some friction, or has caused friction in the past, because it's not always under the control of the developer or always under the control of the DBA. Some other cracks or problems and challenges with ARMs is, how do you abstract away the SQL query language? Do you do querying by example, like you do in Django and Rails, Active Record? Or do you have some API? Or do you invent your own query language, like Hibernate, and have like a subset of the SQL language that you can use and ask your users to use? And one of the more complex parts is, how do you deal with partial objects? If I have a complex relationship mapped in my code, do I load all those relationships up? Do I load all the many-to-many parts up? Or do I wait until I call them? Do I load them up lazily? And sometimes it's not really clear how many queries or how much pain you're putting your database in. I remember when I was working for a radio company in the UK, we were building the website for them, and we built a big CMS, and we were just going through testing, and we had a look, and we turned on the query planner, and we went, right, how many queries does it cost to load the front page? And we'd done no tuning at this time, but it took 418 queries to load one single page. And this was because everything was being loaded lazily, any relationship wasn't being prefetched, it was being another query, and as we're going through many-to-many relationships, you can see how this exploded up and out. And because of this mismatch, you don't necessarily know how much pain or how many queries you're doing, because you're just speaking in code. And so that was a problem for us. Other things are, sometimes you have to jump down to the SQL layer. And how does that marry up to the OO code? Can it actually, the data that you're bringing back from the database, actually come back into an object at all? So ORMs, they are a great solution, but they're not 100% match to the problem of how you're storing your database and how you're using your data. So we've looked at a bit of history very briefly. We've talked about storage has become cheaper. We've talked about that we're building more and more complex applications. What else has changed? Well, we've changed the way we do development. We've gone agile. So when I started, waterfall things, massive death march projects were huge, and were what we did, and we had a deadline. It was a year away, and when that year slowly came closer, we just had to work harder. And I'm really pleased that we're no longer doing that as an industry. We've moved away from that. We're doing a more iterative approach. And what does that really, it doesn't mean what Dilbert thinks it means. It means that we're writing our code, but we're actually delivering more often. We're able to build smaller parts, get feedback, and design, develop, test, and release. At least that's the way you should be doing it. And we're continually doing this process. And the good thing about this is, as a business, you can respond to your markets or whatever needs faster. It does put pressure on, it puts pressure on the code base, but it also puts pressure on the database. So if we're doing and we're becoming more agile, we also have some other challenges as well. We have potentially some scaling challenges, some challenges of dealing with large amounts of data or large code bases with large complex applications. If we're adding new tables and new columns all the time, if you have a lot of data, this can be costly. One famous example from MongoDB is Craigslist, which is a sort of online classifieds over in the States. They had an archive of all their data. They had to keep any data around for a number of years. And every time they did an alter table statement, it took nearly a month to complete. And then it took another month to replicate out to all their slave nodes. So this really slowed down how agile they could be to release code, because they had so much data that the problems and the costs of doing alter table statements were slowing them down. We've also changed how we scale as well. It used to be we would just buy a bigger box, but there's only so big a box you can buy. You have to go horizontal. And if you have a look at people like Google, and these figures are massively out of date now, but Google in 2010 had 100 million gigabytes of data, and they were adding 100,000 gigs a day, and there were no databases they were used. There was no bigger box they could possibly use. And if you think of the figures or see the figures that they have in their index, now it's multiples of this. What databases could Facebook use? Well, they couldn't use a single box. In 2010, they were doing 13 million queries a second. And if you look at the top databases that money can buy from the Transaction Performance Council, the number one database, an Oracle Spark supercluster, could do 500,000 transactions a second. In fact, the top 10 combined could only do 1.3 million. So there's no single box, no single solution to this. You have to shard out horizontally and split your load across multiple boxes. So this background, these changes that have been happening in the industry, that is where MongoDB was born and came from. The formal idea was to bypass these limitations of scaling by producing a flexible database that can scale out horizontally, that is highly available, and can deal with dynamic data. So the core aim, this is quite a marketing slide, was to reinvent data management. And it's true. I'm not overly going to look into the replication or the scaling sharding facilities. I'm sure there's people there that you can talk to about it. But as a high level, what does MongoDB give for high availability? It has a replication method, so a sort of master-slave. It's a single master system. There's always a primary node. There's always a single source of truth. But you can have secondary nodes that read data from the primary and apply those changes to themselves. So if for any reason the primary went down, there was a network blip, a hardware failure, whatever, then one of the secondaries will be able to become elected and become a primary. So you don't have to wake up, and you don't have to wake up the DBA and get them up in the middle of the night. It will automatically switch over to the most up-to-date secondary. MongoDB also provides a sharding mechanism. I'm not 100% sure why this is showing monitors, but these are supposed to be databases. Let's pretend they are. And what this allows you to do is it allows you to split your data across multiple machines, and it has a method for automatically balancing that data across those machines so you can split that data up and spread the load. Now, those are quite complex topics and can take quite a time to explain and go through thoroughly, but the main thing I want to get across today is to talk about the document model and why that's core to everything with MongoDB. So previously, where we had the relational model, where we had multiple tables and we had relations there, the document model allows you to encapsulate your data, the model of how you're using your data and your objects, and store them as you need. So here's Paul again from London, who's lucky enough to have 2 fantastic cars. In his document here, we have keys and values. Those values themselves, Paul is a string, surname Miller, string again. But we can also have some more complex values, like location, which is an array of points. And we can put an index on that, and we can do location lookups on that. We can also store multiple subdocuments. So we have cars, and each car itself is a document in itself. So the document format that MongoDB uses is actually a superset of JSON. So not only does it store true, false, binary, null values, but it also has things like native dates handling as well, and proper binary handling as well. The idea of why you would use documents is you are able to look top-down on something. You're able to store and encapsulate your whole object as a single entity that you want to use. And if you have that in one place on disk, that can be extremely efficient for loading as well. MongoDB doesn't want to get rid of all the roots from the relational database at all. There are things about relational database that we all know and love as developers. We like to be able to do ad hoc queries, and for that, SQL has a fantastic query language that allows you to do rich and complex queries. MongoDB wants to emulate this by having its own rich query language. So you can find values, you can do greater than, you can find everyone who owns a car on a certain date or within certain dates and things like that. There are geospatial indexes you can apply. So you can find all the car owners that live in London or wherever. And there's a text search index that's now introduced that's in 2.6 is becoming out, and it's going to be no longer a feature you have to flag to say you want to use, but it's becoming a fully fledged feature. And text search will allow you to find any cars that have leather seats or whatever description you want to index. There's an aggregation framework which is evolving as we speak and allowing you to do more and more complex aggregations. So if you want to find the average value of Paul's car or anything, then you can use the aggregation framework. And it itself is a framework, it's a language, and you can build up and do complex aggregations with it. And for those areas that you can't do, or you want some more dynamic data examining, then you can use the MapReduce framework and write your own JavaScript functions to do. But we're hoping that the aggregation framework, and we're tuning the aggregation framework to become the richest part for aggregation. So the biggest question then is, now you have documents, and if you've never used the document database, how do you model with them? How do you store, how do you deal with your data? So this is quite a canonical example from MongoDB. I don't know why. It's simple and everyone can understand it. If I have a blog post, I might have an article table, and I might, hopefully, if my blog's good, my article's good, I'll have a number of comments, so I'll have comments, and I might tag my blog posts, and I might give my blog post categories as well. And I'll have an author, which will be a user, that writes the post or writes the comment. Now, underlying, if I was going to store this in the database, this would require 7 tables. I'd have to have a join table for the many, many relationship between articles and categories and articles and tags. So just to get out one article, I potentially could have to go to the database and join up 7 tables. In MongoDB, you have a lot more flexibility. You could store all that data in a single document, or you could say, right, well, the way I'm dealing with this data, I want to keep my users normalized out, because if I change them, I don't want to change every single place that they are stored in the database. But you might want to say, right, I'll have the comments embedded inside my article, and I'll have an array of comments, and I'll have an array of tags and an array of categories. So with documents, there's more flexibility, and there's not necessarily a single way of designing your schema. So if we have a look at some of the relationships that you can design, here's an example. We have one-to-many. We have one shark and many fish. Now, how would you model this in MongoDB? Well, here I have my same blog post, and I have my comments. So here they are. They're all embedded in the same document. Now, this is great for locality. It's in a single place on disk, so going to find it, doing a query and finding it, retrieving it, will be extremely fast. But what happens if I want to find all the comments by someone, some user, by Nero, for example? Well, the problems with doing that is the query language is going to find me everything that matches a document. So I would have to extract those things outside. So sometimes filtering embedded items can be more complex. You can use the aggregation framework, that's true, but sometimes if you need to do lots of that, then that might not be the best model. You might want to link your data. Now, MongoDB doesn't have joins, so there is a cost to doing this. And what we're doing is we're actually storing the comments in a separate collection, separate table essentially, in MongoDB. And we're just storing the IDs of those comments inside my document. Now, this is great if I want to have flexibility and I want to do more analysis on the comments itself. I can do queries, I can get them directly. However, if I want to show the blog post, then it's going to be 2 round trips to the database, because MongoDB doesn't have joins. So there are some trade-offs here, obviously, but this model will allow you more flexibility. Many-to-many relationships. We have many dolphins and many fish in this example. So some real data. here I have a shop and I have a product. I have a graphics card, and the graphics card has categories, and that's fine. And each category will belong to many products as well. So this is a many-managed relationship. Now, I can query either way and find my data either way, but there are going to be problems with this. One side of this relationship is not very balanced. Hopefully, if you're a successful shop, you'll have many products, and those products will have categories. Which the problem is that's an ever-growing or ever updating, enlarging array, and that's not going to be very flexible if I have to do mass updates and mass deletes and things. So this unbalancedness looks like a smell to me. So you are better off in this instance converting it to a one-to-many, essentially, and just storing the smaller side of the relationship and going 2 round trips to the database. It will be more efficient for you. Inheritance. Not many people really do lots of inheritance, but ORMs do make this easier to do, so it can depend on your project, your problem domain. But in this example, if I was going to model some shapes in the database, a wheel, a square, rectangle, and circle, how would I do that? Well, in a SQL database, I might have a table with many columns and just have null values in for those that don't make sense. So I can have a type circle that has a radius of 5. A rectangle has a width and a height. Doesn't need a radius, doesn't need an inner radius. That's fine. That's not a problem at all. You can do that. But with documents themselves, you have the schema embedded in them. They describe their own problem domain. So I can have a type, circle, and that will just have a radius. For a rectangle, I can have the type, the width, and the length. So you can just store the whole object domain in itself. Then, if you wanted to add a new type, for whatever reason, you want to add box. I know this is a simple example, but if you ever wanted to do that, there's no migrations to do. You can just add a new document. And here I have the type box that has a length, width, and a height. So this flexibility allows you to have data that have different forms easily and efficiently in the database, and it allows you to change and be flexible and change in the future. Now, all sorts of architecture fits in the document model. Just very similar to the SQL model. You can do some exotic data structures, I'm sure. Just because you can doesn't necessarily mean it's a good idea, is all I'll say. Very much like this upside-down house. So, if you're looking to leave SQL or try out MongoDB, let's have a look at why you might do that. Why would you use documents? Documents are great because they can be self-contained pieces of data. They closer map to the use case, the structure of the data and how it's being used. If you remember the SQL schema for the car that was in bits because you've normalized it out, or the car put together. These, you can map closer to how you want to use these objects in your code. You also get a flexible schema. The schema is defined in the application code, and you can add, remove, replace fields in the database without schema changes. So over time, you can add, and as long as your application can deal with data that's there, then you can handle schema changes efficiently and easily. This makes it very easy to prototype and be iterative over it. You can deal with those changes. But it also means if you have masses and masses of data, that having documents can be reactive to change because you don't have to update all your data, your terabytes and petabytes of data, to a new schema. You can just add new documents which are a new version of that schema. However, any document database, MongoDB as well, is not a silver bullet. It's not a panacea that will fix all your cure all your ills. So what you should avoid, you shouldn't do and use a document database as a relational database. Relational databases have had 30 years, 40 years of growing and of experience and of lessons learned. So do not normalize all your data modeling and do lots of in-app joins. Don't try and do all the joins that you would do in a relational database in your application because MongoDB doesn't support them. That kind of tells you that maybe you should be using a relational database. Sometimes massive documents, it depends on your domain, or continually growing arrays can be a smell, and that can have performance impacts as well. If your document's continually growing, then it may have to move about on disk to have space for it to be stored, and then you may see a lot of moving documents on disk in the underlying database, which may impact your read or your write performance. Other things are to avoid is the level of granularity that you do for designing your documents. Don't go too high or too low to begin with. Look at how you're using your data. So some hints and tips quickly. Denormalize your data first. Go from that approach. It's the opposite of the SQL approach, but look at using your data and denormalizing it, but then map your document to your OO model as well. And then if you're finding some pain points, look at normalizing it as you need to. So potentially breaking out some sub-documents into a collection, or normalizing things that are changing all the time so you only have one place to change them. Using an ODM, an object data mapper, the equivalent of an ORM for a document database, is not an excuse not to understand what's going on underneath. And as ever, with anything in this world, use the right tool for the right job. So that's nearly me finished. If you want to know anything more, MongoDB does free online training at education.mongodb.com. There are courses for Java developers, Node.js developers, Python developers, and there's courses for DBAs as well. They're free. Have a look at when the sessions are, and basically you watch a video and you do some exercises. I can highly guarantee it. Right, that's me. So if there are any questions? No? Well, I'm done.
Just a second.
All courses then I see on the screen is for developers. Are there any courses for system administrators?
Yes, well there's a DBA course. That's a great question. And there is a DBA course for administrating MongoDB, rather than just developing applications with it. So do have a look, yeah.
What languages are available for courses?
What languages are available for courses for developers? Java, Python, PHP?
So at the moment, it's Java, Python, and Node.js. I believe some more languages will be coming on board, but they seem to be the most popular.
When you show about inheritance, can you talk about how to choose the type of object when I retrieving a collection of different objects? I'm using C# driver and I want to have strong typization. How should I know about type of objects when I retrieve it?
Okay, so if you're storing everything in the same collection and you want to know what type of that, how you should move that object into one of your objects in your code, then some ORMs and things will store an underlying type and use that type information to create an actual object itself.
One more question.
Sure.
Okay, we have, I'm the Java developer and we have the strong typization language and the pure typization language. And if we use, for example, JavaScript, there is no problem. We can deserialize any object with a JSON and just check if property is undefined or not. And if we have the Java, as the previous question, we should know if this field is exists in database or not. And if we have extremely fast changing schema, there is any option in the MongoDB to check it by the database, but not by the application, because it's a lot of job if we have changing schema maybe a few times per week.
Yes, I mean, again, these are kind of process challenges that you may have if you're just getting back essentially in the Java world a map of string for the key and then any value, then you are in your application going to have to understand how to check if a key is there, and then what type of data you want to cast that into as an object.
So this kind of job should be done on the application side, yes?
Yes, I mean there are numbers of sort of almost POJOs for dealing with and converting your objects back. But if your data is highly changing, then the more dynamic languages deal with this flexibility a lot better than static languages, for example. But there's no reason why you can't understand and look and introspect the data and then cast that into the type that you need to use.
Okay, thank you.
No problem.
One more.
We have a lot of data in MongoDB, and we have a lot of different queries to MongoDB, and we have a lot of indexes to support these queries. Is there any cases to use multiple indexes for one query? For example, to compile indexes in support one query?
So the cost of having indexes is very similar. I mean, you're writing in multiple places. So if you add a new document and you have 10 indexes, then there's 10 places you're having to write as well and update and maintain. So this can slow down your write performance, but it will.
We have a good performance. Okay, we have a good performance for reading because we have a lot of, for example, replicas in the set. But the bottleneck is write performance, and if you have a lot of indexes, it's hard to support the whole system.
Yeah, I mean, it's very similar to the SQL world in that kind of aspect, that you have to finely tune your indexes and your schema to be able to get the most out of it, so you're not causing a bottleneck for when reading. But it does depend on how you're using your data.
Okay, thank you.
Anybody else? Oh.
Thank you for your presentation, and I would like you to ask some question about how to store binary data in the MongoDB, because as far as we understand, it's a JSON-based database. So can you give us some tips and recommendation about how to store binary data?
Yeah, sure. I mean, MongoDB uses a binary format itself called BSON, which is a superset of JSON. So it allows for more types. One of these types is binary itself. So if your documents are never going to be, or the data you're storing is never going to be more than 16 meg, which is a hard limit on the document size in MongoDB, then you could store your data just directly in and use your driver to serialize the binary data in. Now, because binary data often comes in sizes and flavors a lot bigger than 16 megabytes, the drivers themselves all have a process called GridFS, which is built on top of the database, so it's not a database technology. And what that does is that chunks up the file and stores it in the database in one collection, and you'll have metadata in another.
One more last question.
Hi. There are some mobile solutions, NoSQL mobile solutions like Coach DB Lite. So when we will see MongoDB for iOS or for Android?
I hope soon. But at the moment we have some other projects going on, so there's no deadline or no set period for this. But I know there's a number of people inside the company that would like to see this happen. And one of the good things about some of the refactoring that's happened on the kernel itself is in the future, this should be easier to do and then maintain. A sort of MongoDB Lite would be awesome.
Thank you so much for your presentation. It was very useful and it was good. Thanks a lot.
Worries.
Yeah, there are a lot of us and we applaud you. Unfortunately, we can't move a camera to the whole people. That's why. Bye.
Bye. Thanks very much all.
Bye bye.